This is a video about congruent shapes. So congruent shapes are shapes that have the same shape and size. It's pretty easy to look at a shape and try and figure out what a congruent shape might look like. Let's try that. Let's start with a shape like this. Maybe I have a triangle, and I'm going to label some vertices. Here's A, B, and C. Now, if I make a copy of this shape, if I say, here is my triangle, here's another copy of it, then obviously these are going to be congruent shapes. I can label these points D, E, and F, and then I can make all kinds of statements about their congruency. I could say, here is line segment AB. That is going to be congruent to line segment DE. So line segment AB is going to be congruent to line segment DE. I can say that angle B right here and angle E right here are going to be congruent. And things like that, they just kind of work out without too much trouble. But I could also have a shape like this that isn't quite as easy to see the congruency in. So maybe I see a shape that looks like this. Now, am I able to see that this shape and this shape are congruent? And they are, and you just watched me copy paste these so you know that they are. But we also have to find where the congruency is. In this case, it's a little bit easier because there is this right angle. This right angle was point C. If I want to call that C prime is congruent to C, B prime is congruent to B, A prime is congruent to A. This shape and this shape do not, at first glance maybe, look to be congruent. So there is a question of how can we tell that they are, and that's actually what a lot of this chapter is about. One thing we're going to do, in a very simple sense, we're going to say, if I can cut out one of these shapes, so if I can take this shape right here, I'm going to copy paste it again just so that you can kind of see it. But if I take that shape, can I in some way or other manipulate this shape to get it back to the original? Back to this shape. I don't know that it's the original. So I'm going to do that. I'm going to start by rotating it because it looks like it. If I flip it, so this is like if I had taken this shape and cut it out, I can force it to fit exactly right back on the initial shape, and that means that these are going to be congruent. That's the basic principle. Now we want to be able to do all kinds of different things with this, and one of them is naming congruent parts. So if you are a note taker who really likes having headings, then here is a heading. Naming congruent parts. If you know that these are congruent, and again we're going to talk about how you know that in some of the next couple sessions, lessons, videos, whatever you want to say. If you know that these two shapes are congruent, we'll say this one and this one, I'm just going to ignore this one, then we need to be able to label the congruent parts. I can say that line segment AC is congruent to line segment A prime, C prime. I want to keep these orders the same. I can say that, these segments are the same. I can say AB and A prime, B prime. The measure of angle A is congruent to the measure of angle A prime, or rather the angles themselves are congruent. I can do different pieces like that. I can in total say that triangle ABC will be congruent to triangle A prime, B prime, C prime, again listed in that order so that we do see that. That's the basic congruency idea and naming the congruent pieces. I want to be able to run with this a little bit more and find some congruent triangles and make sure that these are okay. Here we go. Maybe I have something like this. And let's draw another line this way. And we'll say maybe we know that this one comes in at 90 degrees, this one comes in at 90 degrees. Now I know that this isn't exactly drawn to scale. I also know that math texts in general are notorious for saying, here is a picture, don't trust the picture. And that's a good lesson anyway. Don't trust the picture in a math text. Just every single time, go with the numbers. You don't know you can't know conclusively what something means just by eyeballing it. A math class will always be opposed to that. So you are using the numbers that are given and nothing else. So what can we say about this? Well, maybe we know that this side and this side are of equal length. Maybe that's a piece of information that we have. Here's some spots, A, B, C, D, and E will be our vertices. And this is the given picture right now. I'll leave that part in white. So I might say, well, line segment AC is definitely congruent to line segment DC. That was given to me. If I want to label some angles, angle ACB, this one right here, is going to be congruent to angle DCE, that one right there. And I want just a little bit more. If this line comes in and this is perpendicular, then I can also say angle ABC, so right here, is going to be congruent with angle DEC right here by means of alternate interior angles. So I have that these angles are congruent, that these sides are congruent. I can say this line segment and this line segment are going to have to be, and also this line segment and this line segment are going to have to be. I'm going to keep going. Angle A is congruent to angle D because all right angles have to be congruent with each other. So I have all three angles taken care of. Now on the sides. Let's see what I've got there. Maybe I'm able to remember this. Maybe I can say, I know that if I have the cosine of my angle, the cosine of my angle is the adjacent side divided by the hypotenuse. So the cosine of angle ACB is going to be side length AC divided by side length BC. This angle is the same. This side is the same as this side is, which means these two have to be the same. Probably for this would still be given in the next couple sections. That's something that's going to come up. Line segment BC is going to be congruent to line segment EC. And Pythagorean theorem says this squared plus this squared equals that squared. If we've got that these are equal and these are equal, that means that AB is going to have to be congruent to DE. These are all three sides. All the angles, all the sides. That's every part of the triangle. Pythagorean theorem. That's all the parts of the triangle, so I can say definitively triangle ABC will be congruent to triangle DEC. I could also say this. Let's say I have this line and this line, and we'll connect them. Alright, these are vertical angles right here. We're going to have to label some points to be able to do this a little more easily. So we'll go A, B, C, D, E. So angle, I can say for sure angle BAC is going to be congruent to angle EAD, and I know that because these are vertical angles. Let's say I am also given that angle B and angle E are congruent. So angle B is congruent to angle E. We'll say that's a given. Well, if I know this angle is, and I know this angle is, I know all the angles inside a triangle have to add up to 180 degrees. So this angle in here, angle C, is going to be equal to 180 degrees minus angle B minus angle BAC. I can do the same for this triangle over here. I can say angle D is going to be equal to 180 degrees minus angle E minus angle EAD. But I've already said these two are congruent, so they're the same as each other. These two are congruent, so they're the same as each other, which means these will have to be the same as each other. What that means is that I can say, if I know that two angles of a triangle are congruent to two angles of another triangle, then the third angles have to be congruent too. We're going to call that good for this video. We'll come back and do some more and build on it, because most of what we'll be doing for the next little while will deal with proving that things are congruent or aren't.